Hello everyone, welcome to our biochemistry lesson. And now we were going to continue with our amino acid series. We need to know all the amino acids and we need to memorize them all. So, in order to do that, I will show you a very easy way to do it. Firstly, we have amino acids with electrically charged side chains. Let me write it. Amino acids with electrically charged side chains. Okay. Now, before I write you these ones, I want to show you something else. And now we have our all amino acids. And let's start with electrically charged side chains. This is basic or acidic amino acids. Now let me show it like that. We have acidic or basic. And first we will write basic amino acids. And then we will have acidic amino acids. Okay, now how can we find them out? How can we know all of them? Now I will show you how. First of all of the amino acids are L structure. Okay, so it means when we do our R or S configuration, which corresponds to L and R configuration, we will need to pay attention here. So it will be something like this. We have our beta carbon and we have our alpha carbon over here. This makes a carboxylic acid group, and then we have a nitrogen group, NH2, and then we have a hydrogen group, and then we have an R. As you notice, we put the hydrogen group backwards, which it makes it number 4, and then we have N over here, carbon over here, carbon over here, which makes nitrogen number 1, and then we have 2 carbons. This carbon is attached to oxygen, which makes it number 2 and 3. Seeing and determining its direction, we make 1, 2, 3 in this way, which makes it L configuration. I drew this just to show you that the amino acids are actually always L structure like this, and there are some exceptions, which we will come to that later on. Okay, and now let me go on with all of the amino acids. First of all, we have the basic ones, basic amino acids, and then I will write, we have the arginine, like argentum means silver, and then it is you can imagine it's like a silvery structure, even though it's not. I just made it up in order for you to memorize it better. And now we have an acidic group, carboxyl acidic group here, and attention to it being L structure. And then we have our R group. Our group is has 3 carbons and then a guanidine structure. Like we have 1, 2 carbons, and then we have our guanidine structure, which is as follows. Okay, and as we notice here, this one will actually go away, and we will have like this one positively charged, this one negatively charged. And as we know, nitrogen makes nitrogen has 5 valence electrons, and therefore we will have still 2 valence electrons over here, and then we will have 2 valence electrons also over here, 2 valence electrons over here. And here the thing that we should know that is that there is a resonance structure over here, and this is a basic amino acid. Alright, now let's move on to the second basic amino acid, and let's make it smaller so that all of them can fit. Anyways, let's now go on with histidine. What is histidine? Histidine is a basic amino acid. Now, how can we memorize them? We said argentum, which means silver, makes resonance. As we see here, it has a guanidine group, and therefore it is silvery. It is shiny, let's say, as like it is as if being washed by soap, and soap is basic, as you know, as if washed by soap, which is basic. And let's move on to histidine. This will be our small memorizing helper. And histidine is like the all amino acids. However, it has a stiff R group, and I will draw you its R group over here. We have our carboxylic acid, and then we will have our R group. We will have our nitrogen amino group attached with a positively charged, and then we have 1 carbon over here. With arginine we had 3 carbons. Let's count them. I will show you how to count. We have first carbon, 2 and 3 carbons over here, which I'll just write them here. But in histidine we just have 1 carbon and a phenyl group attached with lots of nitrogens in it. So let me write it just over here. We have a nitrogen, we have another nitrogen over here, and H, and then we have a double bond. Okay, this one is histidine. And I'll just need to tell you that we have 1 carbon over here, and then we have lysine. Then what's up with lysine? Lysine has lots of amine groups, which turns out to be a problem when we will come to our enzyme subjects. And then we go on like this. I'll show you how to draw it. We first of all, we have an amine group, as I already said, and then we have 4 carbons this time. 4 carbons, like now. Okay, anyways, I'll just draw it like that. So in arginine we have 3 carbons, in histidine we have 1 carbon, in lysine we have 4 carbons, 1, 2, 3, 4, and then we have an amine group also in there. And these ones are all basic amino acids, and now let's see what is our acidic amino acids. So acidic amino acids, we have just 2, which is first aspartic acid and the second one is glutamic acid. Alright, now our aspartic acid, both are acids. As we know, the R group will include this structure over here. We know that, but there's a slight difference. Now, aspartic acid has just 1 carbon in its R group, whereas glutamic acid has 2 carbons in its R group. All right, now how to remember this? Aspartic acid has an A, which is the first letter in our alphabet. So first letter means we have just 1 carbon in our R group. All right, now let's start. Over here we have a carboxyl group. Over here we have our amine group, and then we will have, as it's the first letter, we will have just 1 carbon in the R group, 1 carbon, and then we will have our acidic group over here, and then I am writing the positive charge here, we have the negative charge here, we have the negative charge here, as it has fulfilled its acidic task. Alright, now let's continue with glutamic acid. As I said, it's just same with the aspartic acid. It has just 1 more carbon than itself. So I'll just draw it like this. We will have our amine group, and then we have 2 carbons, and then let's write the carboxyl group. And this is our glutamic acid. And then let's continue. We have our polar amino acids. And in our polar amino acids, what makes polarity? Now, first of all, as we know, hydrogen bonding makes a molecule polar. So let's dig in deeper and see all the amino acids which are polar. Let me write it over here. Amino acids with polar uncharged side chains. All right, and then we have serine. We have asparagine and glutamine. Now, as you can see the similarity over here, we had glutamic acid and then we have aspartic acid. It's just that instead of O over here, instead of this part over here, we will have an amine group. This is our only and one and only difference in those two. All right, now let me draw you nearer so that you can see the difference. Now in asparagine, we will have as always an amino group over here, and then I'll draw just one carbon as it's the first letter in the alphabet, and then I'll draw a I'll start drawing carboxylic acid, but then I'll change it to an amine group as to remember it from the aspartic acid. Similarly, I will start drawing a glutamic acid, and then I'll change it to have, as we have two carbons over here, and then we have this, and then we have an H2, an amine group, which makes us our glutamine. And then what is a serine? Now, as we know, the polar group is mainly because of our OH. All right, so we need an OH in one of the amino acids. We expect for one of them to be like that, right? And we will have just one carbon so that we can remember them better. And now we have our first amino group, which has NH3 plus, so we have the negative sign here, and then we have our hydroxy group attached over here. All right, and this is our final and then we will have some special cases to discuss. And then what's our special cases? So first of all, we will have cysteine. Now let me write also in polar ones. Let me also write, we wrote serine, we wrote asparagine, we wrote glutamine, but there are two more. There's threonine and tyrosine. So first of all, what is tyrosine? Tyrosine is an amino acid which has a polar group, even though it has a benzyl group attached to it. All right, so let me write it over here. We have tyrosine, and let me just write its write its properties. And O, and we have the negative charge over here, and then we have our NH2, and then we have our one carbon, and then we have our phenyl group with an OH attached. So here we have the tyrosine. Tyrosine is polar. It has the OH group attached. All right, and then we will have one last, which is threonine. Threonine. All right, great. And then what is threonine? We have our, as always, we have our carboxylic acid group, and then acetate, carboxylic acetate, and then we have our amine group, and then we have our one carbon, two carbons, and an OH group, and this is threonine. Now let me revise what are our polar side chained amino acids. So first of all, there are three which are really easy to memorize, which is serine, asparagine, and glutamine. Asparagine and glutamine are easy to memorize, as we have instead of aspartic acid, we will have just the amine group over here. Similar to glutamine, we will just add the amine group. And then we have serine, which we will have just one carbon as well as an hydroxyl group, which is really easy. And then we have tyrosine. Tyrosine is a very different case as it has a benzene group. However, as it is attached to a hydroxyl group, we still count it as a polar molecule, even though it has a big benzene group, all right? So, and finally, we have threonine, and we have another hydroxyl group. However, instead of being attached to the gamma carbon, it is basically attached. Sorry, 2, 3, 1, 2, 3. Oh yeah, we have a methyl group more attached to it, which is the only difference from serine. And then we will skip to non-polar amino acids. So which are the non-polar amino acids? You might imagine that there are a lot of non-polar amino acids because there are 20 in total. So let me write non-polar amino acids. So let me start with glycine. Glycine is a very important one. Now, I will show you one in a minute. And yeah, let me start. Glycine. What is special about glycine is that its R group is in hydrogen, which makes the carbon, which makes the beta carbon, which is the central carbon of the amino acid. Okay, central might be a wrong notation, but the beta carbon has 2 hydrogens in glycine, and it makes it non-chiral because it doesn't have 4 different subunits attached to it anymore. So it is an non-chiral amino acid. So let me write it over here real fast. We have the amino group over here, and we have an hydrogen group. And this is our amino acid, which is non-polar. Its side chain is non-polar because, as we can see, its side chain is just composed of a small hydrogen, which is obviously non-polar. And then we have alanine. Alanine is quite simple also. Its only difference is that it has a methyl group instead of a hydrogen. Alright, we have NH2, NH3 plus, and then we have a methyl group attached. Alright, a methyl group attached, we have alanine, which is abbreviated as ALA, and glycine is abbreviated as GLY. And then we have valine. So what about valine? What can it be one step more complex than alanine? Now, I will give you a simple memorizing trick so that you can remember it better, which I learned from Alper Khan Gümülü, just to give him credit. And then we have our carboxyl acetate group, and then we have our V structure like valine because we have the amine group over here, and then we have our like this CH3. As you can see here, we have a V structure, which makes us memorize valine. A V structure which is connected to valine. Alright. I just noticed that I misspelled it. Valine. Oh, sorry. It's written as valine. Now let me continue with cysteine. Now cysteine is a very important amino acid, cysteine. Okay, what makes cysteine so important? Cysteine has a sulfur in its R unit, which is one of the two amino acids which contains sulfur in its R subgroup. So let me write it over here, and then we will have our amine group. All right, and then we will have just one carbon and sulfur containing group. All right, as simple as this. We will have, let's write it so that it will be easier for us to memorize. Now, you need to know the difference between glycine and cysteine. Like cysteine has more S sounds, so it has a sulfur in its R group, whereas glycine has 2 hydrogens. All right. Now we will have proline. So what is proline? Proline is a very stiff amino acid. You might remember it like praline, which means chocolate, and then chocolate is very stiff. Why? Because we have this cyclic structure with a nitrogen, and I'll just write its cyclic structure over here. All right, let me find it. Yes, I found it, and we have our carboxyl acetate, and then this is our NH2. All right. And this is our proline. And then let's continue with our other structures, and we have leucine, and then we have isoleucine. Leucine is connected with valine. Let's think about it like that. And then let's see, valine had a V structure, and leucine is like a V. Let's imagine it like this. If I've just seen him over here, it's like a V, but it's extended, right? You can memorize it. You can, like, I'll show it again. This part looks just like a V, all right? But it's extended than a V, so it's made an L, so it resulted in an L, all right? This might be a very easy way to memorize the structure of leucine. Now, I will show you why in a minute. Now, leucine is like a valine, but just extended of it. All right, makes sense. And now I will show you how that happens. And then we will now have an H3 positive charge in here. And then as we know, leucine was something like that. Sorry, valine was something like that, right? But now just extend it a bit, but by 1 carbon, and make the V structure over here, and this is your leucine. It is as simple as that. Now leucine is abbreviated as Leu, the first 3 letters of it. And similarly also we have pro over here, and we have cis over here. These are the first 3 letters of the amino acid. All right, and then let's continue with isoleucine. Isoleucine. This is very, very easy, as we just take one of the methyl group and attach it to one closer carbon, which is this one. All right, now let me do that, and we will observe that we will have our structure Okay, similar. Okay. And we will have 1, 2, 3 carbons, as we already did 1, 2, 3 carbons, but the methyl structure will be attached to here. And this is our isoleucine. And the shortened notation of it is IL and E. ILE. ILE is the shortened structure. And then we have methionine. Methionine is very important as it is the other amino acid which contains the sulfur in it. And let me write methionine. How can we know methionine? We need to know the number 2. And we will sort this out. How? So 2 signifies the number of carbons before we arrive to the sulfur. Alright, now we are halfway done. How so? Let me just draw the amino acid, and then we will just draw our amine group over here, NH3 plus, and then we will have 1, 2, and then we will have a sulfur. Alright, this is it, and then we will have our last methyl group, and I just draw it over here. And then now that we have also methionine, we will have tryptophan. Tryptophan is a bit tricky to draw, but we will manage. Now tryptophan. Now you can think it as if being trypto, like tripod, like the one device that helps to keep electronic devices up so that we can use the camera. So it's very complex, and it will need a stand to stand on, something like this, right? So that we can put the camera over here. So we have more bulky structures over here, but then it's getting smaller and smaller. And now I'll use this analogy to show you how I imagine it to be. And then we will have our carboxyl acetate group over here, and then we will have, as always, our amine group over here, and H3 plus, and then we will have 1 carbon. Like imagine the triple being going on over here. We have just 1 carbon over there, right? Now let's imagine it to be that way, and we have 1 carbon over here, and then this 1 carbon is connected to a cyclopentane, and then very important, we have a double bond over here, and then a double bond and a single bond, and we have the nitrogen over here. All right, now never forget that we have a double bond and a nitrogen, and then the other part of our bond of our cyclopentane is connected to a benzene. All right, now let me draw the benzene over here, and the one of the benzene double bonds will be connected to here. The reason why, so that it can make resonance. All right, it will resonate. And then we have the bonds over here too, and then oh, I forgot to write the H hydrogen over here, but then we have an H because, as we know, the nitrogen has 5 valence electrons, and it has 2 more, so that they can be added to the resonance. And finally, we will have phenylalanine. Phenylalanine. So there's one important aspect that I want you to remember at this point. What was alanine? Alanine had just 1 carbon, as you can see it here, right? Just 1 carbon, which is this one. Now you need to remember that alanine signifies a 1 carbon, and phenyl, as we know it signifies this group over here. So if we combine these two knowledge, these two information, we can easily see that we will have one carbon attached to the beta carbon, and then we will have a phenyl group that comes consequently. All right, I'm just drawing my carboxylic acetate, and then I'm drawing my amino group. Write it with a positive sign, and then we have just one carbon over here, and then I'll just write my phenyl group. Alright, I'll draw my double bonds, and then I'm done with the phenylalanine. This is also nonpolar, as it has the phenyl group, which is a nonpolar group. And then, of course, our one carbon is also nonpolar. And now we need to know the Zwitter ionic form. Amino acids have both acidic and basic groups, hence exist as Zwitter ions, close to neutral pH. At high pH, both groups are deprotonated, and at low pH, both groups are protonated. Low pH means that the matrix is acidic, that the solution is acidic, right? If a solution is acidic, we expect naturally that the molecule, the amino acid, will take one proton, which is positively charged, and hence it will become a positively charged amino acid. And likewise, as we go to the basic side, both groups will give out an hydrogen. Both groups will give out a hydrogen, and therefore will be negatively charged. And then an important thing over here is that we need to know how to decide the pI of an amino acid. So what is that? So eventually we need to make a small calculation. But before going on with examples, let's take a break and then continue. See you in our next lesson.